Hello and welcome back to Baldy Cats. Now, two things. First of all, for those of you who are wondering why this video is on the Baldy Cats channel and not the Conspiracy Cats channel, it's because the precursor to this video, the prequel to it, came out yesterday, was also on the Baldy Cats channel. This is not going to become a Flat Earth channel. It will stay as a science channel. This is a one-off. And the second thing, you should always heed warnings and read instructions. Otherwise, you might end up saying something like this.
Conspiracy Cats doesn't really know what he's doing, and I'm going to demonstrate that he doesn't understand perspective, he doesn't understand angular size, and that he's completely got this wrong.
Or this.
I'm going to look forward to how he deals with this, because this is terrible for Conspiracy Cats.
Now, yesterday, I released a video that showed this picture. Now, I said, and I explained, why that photograph should be absolutely impossible on a flat Earth. And I also said I'd get lots of rebuttals, which would be ludicrous. And I did.
Let's just see how ludicrous my rebuttal will be. And he's going to dismiss it. I can tell you now he will dismiss it. But he's not going to be able to.
No, I'm not going to dismiss it. I'm going to dismantle it. But first, we need to take a close look at the picture. Now, what have we got here? Well, we've got Mount St Helens, which is in front of Mount Rainier, and is less than half as big. Now, I said yesterday that this was impossible on a flat Earth, and we used some trigonometry to show why. But I left a bit of a sneaky trap. Many times, and in the description, I referred to the fact that I was using the numbers from the photograph. The numbers from the photograph are very important. I want to point something out right here and now. That green writing in the middle of that photograph that talks about the height of the side peak of Mount St Helens. You can see the little green line next to it, and it's almost bang on level with the top of Mount Rainier. I was using that number, that 6,505 foot that I turned into meters. That is what I was using. And the whole premise of my video was to show that Mount Rainier should tower above that point by about 877 meters. Now, I was a little bit cheeky. I didn't exactly say I was using the side peak. I was hoping that somebody out there might find this video and just have enough rope to slowly hang themselves with. So let's see what happened. So here's what I was hoping. I was hoping that a flat earther will get hold of this and have a look at that 6,505 foot and agree with me that Mount Rainier should tower above that by the 800 odd meters that I calculated in yesterday's video. But then I wanted them to point out that actually Mount St Helens is much taller than that 6,505 foot. You see, I didn't make it obvious we were using the side peak, but once they make that admission, then we can look at the side peak and we can question, why does Mount Rainier not tower above it? I wonder if anyone fell for it. Alright, so let's see what we're looking at here. That triangle represents the location of the observer. We know the observer height. Now, all of the numbers on this picture we can prove without a shadow of a doubt.
Right, so his first claim is that all of the numbers we can prove without a shadow of doubt. Now, I've checked Mount Rainier, and Mount Rainier does appear to be the height that he gets, and it does appear to be the distance that he gets.
Yes, it is, because I was telling the truth.
It appears that Mount St Helens isn't the height that he claims, which is a problem, because the maths that I'm about to demonstrate relies on this value being correct.
I caught one. So I can't wait for the rebuttal to be, please prove these numbers.
Oh, right, so you can't wait for the rebuttal to be, please prove these numbers. Well, okay, well, let's address that.
What can I say? I even put the warning in the video and in the description.
And what I observed was that the elevation appears to be, the highest point appears to be 2549. However, Conspiracy Cats has got this measured in at 1982.
And that's because if you were looking at the photograph, like I said over and over, I'm using the numbers from the photograph, I was referring to the side peak of the mountain, not the main peak. It's going well for me so far.
So what we'll do is we'll take Mount Rainier, because Mount Rainier is the one that is considered to be accepted.
So he starts by taking Mount Rainier and putting it into an angular size calculator to see what the angular size should be, because, as he's just admitted, those numbers for Mount Rainier I gave are fine.
So he's got Mount Rainier of a height of 4392. Oops. 4392. Let's go back to that. So the size is 4392. And the distance in meters he's got as 167371. So 1.167371. And when you calculate that, it gives you an angular size of 1.50.
Now, what he's done there is calculate the angular size of Mount Rainier. Now, when he repeats this for Mount St Helens, if that angular size is smaller, that means on a flat Earth, we must see Mount Rainier higher than Mount St Helens. But using my numbers, we should see it higher than the side peak. But he doesn't know that yet.
Conspiracy Cats has got it as 1980, which gives it a height of 1.3.
He actually means an angular size of 1.3, which is great, because that gives St Helens a smaller angular size than Mount Rainier, meaning on a flat Earth, Mount Rainier definitely should be higher than that side peak. Let's carry on.
Which, if you compare to 1.5 degrees, you can see that it's a little bit smaller. So when we go back to Conspiracy Cat's video, and we actually look at the evidence, which would be, there, you can see that let's pull the thing back up on screen. You can see that Mount Rainier should be 1.5 degrees. So that would be there, down to wherever the base is. And then the height of the Mount St Helens in the foreground, with Conspiracy Cat's claim of 190 meters, should be 1.3. But he's got it clearly bigger than 1.5. If 1.5 is that one, he looks like 1.7. So that is inconsistent, and he would be right if we accept the height that he's got claimed in his orthographic side view perspective denying nonsense drawing of 1982, because that would be then supporting his position.
Bingo. You see, what he's just admitted there is that at that height, which is the height of the side peak, Mount Rainier should be that 870 odd meters taller, but it isn't. It's the same height. By his own calculation, he's just admitted that this is impossible on a flat Earth. We can clearly see here that the top of Mount Rainier is not towering above that side peak of Mount St Helens. It's nowhere near that. That is so good, we need to hear it again.
And he would be right if we accept the height that he's got claimed in his orthographic side view perspective denying nonsense drawing of 1982. Because that would be then supporting his position based on angular size, which is perspective.
And there's the next golden nugget. He's accepting that my argument does include perspective. It includes angular size, which is perspective. It's amazing. Thank you.
However, if we substitute his size, and instead of putting 1980, put it at its actual size according to Wikipedia, basically, you would expect actually Mount St Helens to appear bigger than Mount Rainier.
And it does! Let's look at the photograph again. This is amazing! Now, I'm going to set a second trap, but I'm going to be honest about this one. And it's based on what he says next.
The problem is, if you go to the curve calculator and you put in the distances for these things, so the target distance is 167 kilometers for Mount Rainier, and then the eye height of 0, just to get you the actual drop. If we live on a sphere, then you've got that drop figure of 2,188 meters.
So what he's saying here is, we have the observer, we have St Helens, and we have Mount Rainier. But Mount Rainier is quite far away, and therefore it's over the curve of the Earth. So we lose a little bit of height. Yeah, so far so good.
So basically, you've got Mount Rainier that should be 1.5 degrees, but then you've got to add the curvature to it of 2,100 meters, 2,200 meters. But it's only 4,392 meters in absolute height anyway. So basically you can cut down that absolute height into half. And then the angular size is going to significantly change. And basically this ends up being a flat earth proof.
I didn't put that music on, it was on the original video. But here's where it gets worse for you. You see, you've done the calculation on Mount Rainier and looked at how much it should have dropped due to the curvature of the Earth. But what you haven't done is a calculation on St Helens. And I am telling you now, here is the trap. You need to do those calculations. And when you do those calculations, you will find the situation gets so much worse. It only adds to the evidence that the Earth cannot be flat, that this photograph is impossible on a flat Earth. And if you don't do the calculations, you know that we will do those calculations. And they've already been done. And it matches up perfectly with what we'd expect on a globe. So ultimately, you've admitted that Mount Rainier on a flat Earth should be above that side peak, but it isn't. You've not yet calculated the drop for St Helens, which you will do, and that will add to our evidence. You've basically admitted that this isn't possible on a flat Earth. I think that's it. I think that's game over. At this point, I'm going to play the ending of the video that we've just watched here, because I think it was meant to mock me a little bit, only gently, but I think it's a good time to play it. Those rebuttals will be ludicrous, and we're going to prove the ludicrous. But those rebuttals will be ludicrous, and we're going to prove the ludicrous. But those rebuttals will be ludicrous, and we're going to prove the ludicrous. Game over. Tell me, My Little Pony's on in half an hour. Do you want to come round and watch it? Yeah. Yeah, what have you been up to? Oh, good, yeah. Me? I've just ended Flat Earth. Yeah, it was easy. Okay, bye. Oh, trap number 3. Please ask us to verify the observer height. That's a trap. I'm going to be honest about that one. Please ask us to verify that. Please ask us to verify anything. That's the third trap, because we can do that very easily. Thank you for doing the maths. Thank you for admitting that that is impossible on a flat Earth. Catch you later.